So let's try to discuss about how to calculate the power generated by different systems. In this example here is the high head systems. So when we say high head, from the name itself head, it means that it's high elevation. So as we all know, when we talk about potential energy, we are referring for this hydropower based on potential energy is the dam systems. All right. So the main driver for energy generation in terms of making sure that you are generating enough energy is the height of the reservoir. So you need to have an elevation difference between the two parts here. So we have the main reservoir here, and there must be a height difference. All right. So in this case, as I mentioned, you have the confined water here, and then it goes towards the penstock, and then it will turn the turbine here. In this case, for example, you can have a Kaplan type or a Francis turbine as a submerged type. So this is a reaction turbine, which in turn the shaft here will rotate and generate electricity based on the generator system here, and then goes towards the power lines and the electricity grid. All right. So since we are talking about dams, this is based on potential energy. So the potential energy for this case is this one, the E equals mgh. So the mgh for this part here, as we understand, so m stands for mass, right? So mass, so this is mass, and the h is the head. And so of course we know what is g, which is the gravitational constant. All right. And so if we want to convert that to power, then we can just add the per second or the per time, per unit time. So energy per unit time is power. So in this case, mass over time is basically the mass flow rate. Now we can further expand this one. Normally when we talk about dams, so there the system has some losses here, for example, especially the losses coming from the turbine efficiency, the generator efficiency, and so there will be losses of overall losses. So in that sense, then we need to add the efficiency. All right. So hydropower has quite high efficiency. So we can say we can have about 80% of efficiency depending on the type of design that you have. And then the rho here, so rho GH, you can see rho and Q. So rho Q is in fact the mass flow rate. Okay, so this is mass flow rate, right? Mass flow rate. So rho Q, which is also basically the same as this part here. So this is the rho Q. Okay, so rho is density of the water. Rho is density of the water, and Q is volume flow rate. So volume flow rate is cubic meter per second, and rho is kilogram per cubic meter. So if you can cancel cubic meter, it becomes kilogram per second. So we can now see that in fact this part over here, m over t, is the same as rho q. So we can expand like that to get the power. So as a very simple example here at the bottom, if we are given efficiency of 100%, so this is just theoretical, the rho, which is 1,000 kilogram per cubic meter, this is water, and this is the density of water will depend also of the temperature, of course, but generally you can say 1,000 kilogram per cubic meter, and a volume flow rate of 20 cubic meter per second. Of course, this one is just to make sure that this is not the exact gravitational force. So when we say gravitational force 9.81, right? So this is just to make things easier for this example. And so if we try to get everything, we can get 10 megawatts as power output of this specific dam. So it's very simple formula. It's based on the potential energy. All right, so please remember that formula. All right, so the second type of hydropower system, the first one was dam. The second time is based on kinetic energy. So this is more of a low head and run of the river system. So the name for this kind is run of the river or run of river. So ROR or ROTR. So you can say run of the river. So you can all just put ROR. All right, run of the river system. So instead of potential energy, we use now kinetic energy because in this case we are putting the turbine directly on the river flow. All right, so there are two kinds. You can either make a sort of a mini dam on the river, but if you have really strong river pressure, for example, the flow is quite strong, then you can directly put your turbine on the river system directly. So in this case, you are not exactly trying to be a barrier of the river, so the river will just flow through the turbine. In this case, it's a Kaplan type of turbine, which is put in as a vertical type or horizontal type, I mean. So the flow will just go directly towards the river system and then flows directly to the other side. And this one, the continuous rotating of this will just generate electricity anyhow. So based from this system, this is a low head system. So we can generate energy based on the kinetic energy. So 1/2 mv squared, as we know, v is the velocity. So that's meter per second. And so in terms of making it as a power, then we can just add the time part here. So 1/2 mv squared over t. And then we can also now get the rho q, which is m over t. So this part is the same. So 1/2 rho q v squared. So this is now the formula for run of river systems.